Multiplying and dividing rational functions. Okay, first of all, let's talk about how to just multiply and divide fractions. For multiplying two fractions, you cross-simplify and then you multiply across. Cross-simplify just means to look at 2 and 5 and see if they simplify by anything. Nothing divides 2 and 5, so we can't simplify those. Then looking at 6 and 3 and seeing that we can divide them both by 3, sorry. If we divide them both by 3, we get 2 up here and 1 down here. Now we just multiply across. 2 times 2 is 4, and 5 times 1 is 5. So there's my final answer. You could always simplify in the end, so you could have gotten 12 over 15, but with rational functions, it's way easier to simplify, to cross-simplify, before you multiply across. With dividing, we need to keep in mind KFC, keep, flip, change. Keep the first fraction, flip the second fraction, change to multiply. Again, we're going to cross-simplify. 4 and 2, I can divide both of them by 2, so I get 2 and 1. I can divide 21 and 7 both by 7. If I divide them by 7, I get 3 and 1. Now multiplying across, I'm going to get 6 over 1, which is just 6. Never leave your answer as over 1. Okay, so let's start with simplifying before we get to multiplying and dividing. We're going to start with looking at what's on the top and bottom that we can simplify. So look at your coefficients first. I have a 3 and a 12. I can divide both 3 and 12 by 3. So I get 1 and 4. Also with my x's, I have 2 x's on top and 1 on the bottom. I can cancel 1 out of the bottom and 1 of them out of the top. So what I have left is x over 4. Since I don't have an x in the bottom, I don't have any restrictions here. Okay, again, we're going to look at our coefficients first. Between negative 16 and 12, I can divide both of them by 4. So I get negative 4 on the top, 3 on the bottom. I have 5 x's on the bottom, 2 on top. So I'm going to cancel the 2 out of the top, and I'm going to cancel 2 of them out of the bottom. I get x to the third left. Same with the y's, cancel 3 of them out of the bottom, 3 of them out of the top, I get y to the fourth. And z's only on the bottom, nothing to cancel out with the z's. So my final answer is negative 4, y to the fourth, all over 3, x to the third, z to the fourth. Now we do have restrictions on this problem. X cannot be 0 and z cannot be 0. If they were, that would make my denominator 0, and we can't divide by 0. Okay, with this one, notice that we have a minus sign in the top and bottom. If you ever see a plus or a minus, we're going to start by factoring. So if you recall factoring from Algebra 1, it's just pulling out a greatest common factor in this case. So between 3 and 12, I can pull out a 3. I'm left with x minus 4. On the bottom, again, I can pull out a 3, but I can also pull out an x because I have 2 x's here and 1 x here. So after I pull that out, I'm left with 1 x here minus 4. So now, looking at terms that cancel out, my 3's cancel out, my x minus 4's cancel out, all I'm left with is 1 over x. My restriction here is that x cannot equal 0. Okay, same idea, but now we have factoring where we're going to have to see what multiplies to 6 and adds to negative 5. So, factors of 6 are 1 and 6, 2 and 3. If I made the 2 and the 3 negative, they would multiply to positive 6 and they would add to negative 5. So my factors are going to be x minus 2, x minus 3. Same with the bottom, find out what multiplies to negative 15 and what adds to 2. My factors of 15 are 1 and 15, 3 and 5. If I make my 3 negative, leave my 5 positive, those will add to 2 and multiply to negative 15. Okay, anytime we're factoring like this, it's kind of helpful in order to find the factors, look at what factors you have above, because usually something's going to cancel out. That's kind of the point of this problem. So my x minus 3's cancel out. I'm left with x minus 2 over x plus 5. My restriction here is x cannot equal negative 5. That would have made the denominator 0. Okay, so now we're going to start multiplying. So with multiplying, we're always looking for cross-simplifying first. If we look at 96 and 45, we notice nothing divides out of those. Same with 25 and 38. So now we need to look at 96 and 38. I can divide both of those by 2. I will get 48 and 19. 25 and 45 both divide by 5, so I can make that 5 over 9. So I'm left with 48 over 19n, the n didn't cancel out, times 5 over 9. I can simplify again looking at the 48 and the 9. If I divide them both by 3, I get 3 and 16. So then I have 16 over 19n times 5 over 3. Now just multiplying across, I'm going to get 80 over 57n. My restriction here is that n cannot be 0, or else that would make my denominator 0. Okay, with this next problem, notice that we are going to need to do some factoring. So I first want to point out to you that I have x plus 7 and I have an x minus 8. Probably I'm going to have a 7 or a negative 8 as one of my factors at some point, so look for that to be the case. So starting with the bottom left, 7x plus 35. I can factor this by pulling a 7 out. I'm left with x plus 5. On the top right, I need to know what multiplies to negative 40 and adds to negative 3. Well, my factors of 40 are 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, 6, 7 doesn't divide, so now we're back to 8. So those are all my factors of 40. The ones that could add to negative 3 would be 5 and 8 if I made the 8 negative. So my factors here are going to be x plus 5, and x minus 8. Okay, so now I'm ready to cancel things out. Let me rewrite this again so it's a little more neat. Okay, so now we can see on the top that we have a factor of x plus 5, just like on the bottom, so I can cancel those out. X minus 8 is also on the top and bottom. I cannot cancel out these 7s, though. So since the x is attached to 7 with a plus sign, I can't cancel those out. So my answer is going to be x plus 7 all over 7. For this problem, I won't have any restrictions because I don't have an x or another variable on the denominator. Okay, so now with division, we're going to do our keep, change, flip. So I'm going to keep my first fraction, I'm going to change to multiply, and I'm going to flip. So n plus 6 will now be on the bottom. I'm also going to factor this 3n plus 18 in this step. I can pull a 3 out of both 3 and 18, so I'm left with n plus 6. Okay, so now I can simplify. I have an n plus 6 on the top and the bottom. 10 and 3 don't simplify, so I can't do anything there. My final answer is just going to be 3 times n plus 5 all over 10. Again, we can't simplify the 5 and the 10 here because the 5 is attached to the n by addition. So here's my final answer. Again, no restrictions because I don't have an n in the denominator. Okay, same idea, but we've got some factoring going on here. So let's start by factoring this top equation. We need to know what multiplies to 54 and adds to negative 15. My factors of 54 are 1 and 54, 2 and 27, 3 and 18, 4 and 5 don't work, and then 6 times 9 is also a factor. So the ones that are going to add to 15 are going to be 6 and 9 if I make them both negative. So we've got x minus 6 and x minus 9 all over. Factors of 48 here. 48 are 1 and 48. 2 and 24. Well, I'm running out of room here. 3 and 16, 4 and 12, and then 6 and 8. The pair of these is going to add to negative 14 would be negative 6 and negative 8. And since it's division, I need to change to multiply and flip my second fraction. Okay, so now we can go ahead and simplify. I have an x minus 8 on the top and the bottom. I have an x minus 6 on the top and the bottom. All I'm left with is x minus 9 on the top, so that's my final answer. Again, don't leave it over 1. We don't leave things over 1. And I don't have restrictions because there's nothing in the denominator. Alright, pause your video now, try these problems, and then check back for the answer. Okay, here are my answers. A couple of tricky things I want to point out is difference of squares. If I have a squared minus a perfect square, I just take the square root of 16 and I get a plus 4, a minus 4.